Okay, modeling exponential growth and decay. Second part of these notes, look at number 2. You are told strontium-90 is a waste product from nuclear reactors. As a consequence of fallout from atmospheric nuclear tests, we all have measurable amount of strontium-90 in our bones. I bet you didn't know that, did you? The half-life of strontium-90 is 28 years. So what does that mean? That means you have some little amount of strontium-90 in your bones right now. And 28 years from now, if it's decaying at a rate of half every 28 years, you'll have half as much as you have right now in 28 years. And then 28 years down the road after that, you'll have half of what you have today. Does that make sense? So that's what a half-life means. We got to experiment with this. It says find the exponential decay model for strontium-90. So we're going to start with this. A equals amount after time equals our original amount times e to the k times t power. What is it that we know? We know t is 28 years. That's the half-life. That's how long it takes for some amount. Don't write this down. We're going to just experiment for a minute. So if I have some amount like 100 grams and it decays down to be half as much, it will decay to be 50 grams after time. E to the k times 28 years, because time is 28. Well, if my first step is isolate the base, I would need to divide both sides by 100. And so the hundreds would cancel, and 50 divided by 100 reduces to be 1/2 equals e to the k times 28, or e to the 28k. Well, okay, I told y'all not to write that down. What if instead of 100, what did we start with? 200. And we want it to decay down to half as much, 100. Then you would isolate the base of e, divide both sides by 200. 100 divided by 200 will reduce to be 1/2. Let's make it more general. Then what if I have some original amount, which I don't know? And if I want it to decay down to be half as much, then I want it to decay down to 1/2 of the original amount. And then, if you divide both sides by the original amount, the original amounts are going to cancel out. And what do you have left every time? 1/2. 1/2 equals e to the 28k. So this is an exponential equation. I know this because I look in the exponent spot and I see a variable. So if I take a natural log of both sides, natural log of 1/2 and natural log of e to the 28k, then we know that natural log means log base e of e to the 28k. So all we have left is 28k. Punch this into your calculator, you get some number. And then divide both sides by 28. If we know that this chemical is decaying, then what kind of a k value do you expect? A negative. Good. So punch that in. Do natural log 1/2. Close parentheses. Divide it by 28. And you should find that k is approximately negative 0.0248. Did you agree? Now we need to write a general formula. On this one, we don't know really how much our original amount is, but we could put k in as negative 0.0248. So here's our part A says, find the exponential decay model. Here it is. The amount of strontium-90 after time is equal to whatever the original amount is times e to the negative 0.0248 t power. Now that we have an equation, we can answer part B. Suppose that a nuclear accident occurs and it releases 60 grams of strontium-90 into the atmosphere. How long, so you're looking for t, how much time, how long will it take for it to decay to a level of 10 grams? What's the original amount? 60. So 60 goes for original amount, and we want it to decay down to an amount of 10 grams. So the original 60 decays down to 10 in how much time? E to the negative 0.0248 t power. Always you want to isolate the base. This is an exponential equation. I know this because when I look in the exponent spot, I'll see a variable. Isolate the base, so divide both sides by 60. If we reduce, this becomes 1/6 equals e to the negative 0.0248 t power. And we're not going to be able to get like bases. We got 3 ways to solve exponential equations. We're not going to get like bases. We don't want to do trial and error because it would be especially tedious with all these decimals. So do what you know. Take a natural log of both sides. Natural log of 1/6 equals natural log of e to the negative 0.0248 t power. Log base e of e to a power just gives us the power. Natural log and e undo each other. So on your screen, when you do natural log of 1/6 on your calculator, you have some number equals negative 0.0248 t, which then means you're going to have to divide both sides by negative 0.0248. What do you get for t?
72.248.
72.24 years. So strontium-90 is bad stuff because it takes it a long time. And whatever you have, or if some got released into the atmosphere, if 60 grams got released into the atmosphere, it's going to take 72 years for that 60 grams, not to totally go away, but to just decay down to 10 grams. You have a couple of problems on your homework like this. We can talk about a couple of them in a minute. Look at number 3. We'll do that one, and then I'll let you have a little time to work on some of these problems. On number 3, since we can see it, I'm just going to work number 3 in this space right here. Number 3 is on your notes, number 3. So you have an exponential formula here that is used by psychologists. It says, in a learning theory project, psychologists discovered that f of t equals all of this stuff is a model for describing the proportion of correct responses after t learning trials. You're going, I don't know what that means. It's a function, and you don't really have to memorize the function, you just have to be able to use it. If you have 0.8 divided by 1 plus e to the negative 0.2 t power, and you're told this model's how many responses you get correct, what proportion do you get correct? Part A says, find the proportion of correct responses prior to learning trials taking place. T is the number of learning trials. Almost anything you do, if you practice it a little bit first, you're better at doing it. So you're trying to learn some new something, I don't know, tying your shoes or who knows what it is. You're trying to learn something new. On part A, maybe you were... Are you saying that he doesn't know how to tie his shoes yet? It's possible.
I asked him if he needed to practice tying his shoes.
Nice. So if no learning trials have taken place, then what are we going to do to answer that question?
Plug 0 into the
0 in for t. So if you plug 0 in for t, then you're really finding f of 0. That means you're going to do 0.8 divided by 1 plus e to the negative 0.2 times 0. And you can do this one without your calculator because 0.2 times 0 is just going to turn into 0. So that means we got 0.8 divided by 1 plus e to the 0. But what is any number, even e to the 0 power? 1. Any number to the 0 power is 1. So now we are at 0.8 divided by 1 plus 1, or 0.8 divided by 2 makes it 0.4. So with no learning trials, correct responses are 0.4, or I could call it, thanks, Jake. with no learning trials, correct responses are 4 out of 10. 0.4 or 4 out of 10. On part B, it says, find the proportion of correct responses after 10 learning trials. So if t equals 10, it's really a matter of plugging into the formula again. You're going to find f of 10 equals 0.8 divided by 1 plus e to the negative 0.2 times 10. Type that into your calculator. You got to be careful because you got to tell your calculator, do 0.8 divided by all of this. Did you get approximately 0.7? You should have gotten approximately 0.7. Type that into your calculator, right? What does that mean? That means after you've practiced, if you've had 10 learning trials, whatever it is you're trying to learn, after you've practiced it 10 times, then you get 0.7 correct. Or I could say 7 out of 10 correct. On part C, the last question says, what is the limiting size? Okay, in order to answer this question, we're going to experiment. I'm going to assign all of you a value. Okay, so Tucker, your row, y'all do 20 learning trials. Victoria, you do 50. Kat, your row do 100. Ashley, your row do 200. And then Tucker, y'all get to do another one because you've had extra time. So do 10,000.
I think Peyton should get to do it.
Peyton, do 10,000. Y'all's row. Y'all can do, you got 2 of them.
Do we round it up?
Yeah, well, no, give me several decimal places. So what did you get?
I got 0.7856.
I agree with that. 0.7856. Okay, good enough. Victoria, so about 78% of the time you were right. Victoria, what'd you get for 50?
0.79996.
0.7996.
No, another 9.
Another 9, okay. So, about 79% of the time you were right. For 100, Kat.
0.79, I'm repeating.
0.79999. Okay. Okay, for 200, Ashley.
0.8.
You got 0.8. For 10,000, Peyton? 10,000?
I got some weird number.
Did you get it, Caitlin? For if you tried 200? Or I mean, if you tried 10,000?
I haven't done
Okay, try it. Here's how you have to type it in. You're going to have to type in 0.8 divided by all of 1 plus e raised to the power of negative 0.2 times 10,000. And it's going to open a parentheses that you need to close.
Again.
Yeah, that's
You should have gotten 0.8 again. So after a while, it seems to not matter how many learning trials. As you do more and more and more and more learning trials, what happens to the correct responses? 0.78, 0.79, 0.799, 0.8, 0.8. Even if you do 10,000, it seems like we don't get above 0.8. That is a limiting size, okay? So even as you do more and more and more learning trials, at some point, because of the way this formula is set up, you will never achieve more than a proportion of correct responses of more than 0.8. 0.8 is a limiting size for this function. Here's something I challenge you to do. So somebody in my last period said, what if I want to get to 100%? Could I just plug in 100 for the percent correct that I want and solve for t? So that's what I want you to work on for a minute. Try this. I want you to solve, plug in 100. 100 equals 0.8 divided by 1 plus e to the negative 0.2t. Solve that.
So is the limiting,
On this one, on part C, it says, what is the limiting size of the function?
so is it 200?
No,
Oh,
the 0.8. Even as we plugged in more and more and more and more learning trials, the correct responses seem to always stay at 0.8. So 0.8 seems to be as good as we can do. But last period, somebody said, well, what if I want to know how many learning trials does it take in order to get to 100%? So I want you to solve this to answer that question. Here's what you're going to have to do. I'll give you a little hint if you need some help. In order to solve it, you're going to have to clear fractions. So you're going to have to multiply by 1 plus e to the negative 0.2t on both sides. Then those cancel. And so, then what are you going to have to do? If you have 1 plus e to the negative 0.2t, because you're going to have a problem like this on your homework, that you're going to need to be able to do this. Multiply this times 100 to get 0.8. What would we need to do next? After we've cleared the fractions,
You're going to divide by 100.
divide by 100 to isolate the base. So if we divide both sides by 100, then we have 1 plus, I don't need the parentheses anymore, 1 plus e to the negative 0.2t equals 0.8 divided by 100 turns into 0.008. What do I do next? Subtract 1. And we have e to the negative 0.2t equals, that turns into negative point, what do we get?
992.
0.92?
992. 0.992.
0.992, yeah, negative 0.992.
But you can't take a natural log of negative.
So there you go. So what does this tell you? If you try to take a natural log of both sides, then suddenly you're needing to take the natural log of a negative number. What happens if you try to take the natural log of this negative number? You get an error message on your calculator. So you are asking your calculator to do something that is impossible. So the answer is, there's no solution. There's no amount of learning trials that will ever get you to 100% correct, into 100% of your responses being correct. So you have a problem kind of like this on your homework. I'll let you work on it a little bit.
Do you have to, like, do basic and trial and error to find the learning size of